Alright, in this video I want to go over composition of function, and the idea of composition of function is you take one function, you put it inside the other, and the notation is read at the function f composite g integers of x equal to f of g of x, and of course g composite f integers of x equal g of f of x. So this, you take the function g, put it inside the function f, take the function f, put it inside the function g. When you take one function and put it inside another, you replace all of the x of the outside function with the function that you're plugging in. In these three examples, we are supposed to find f composite g integers of x and g composite f integers of x, the domain and the restrictions of these two compositions, as well as these two compositions evaluating when x equals to -2 and x equals to -3. So how do we find the domain of this? Well, the first thing we are going to need is the domain of both of the function f and g. So for the function f, if we take a look, we don't have any denominator, so we can take any x value, plug it into the function, and crank out the corresponding y value of that x value. And same thing can be said for the function g. So the domain of f is -infinity to positive infinity, which is all real numbers, in another word. And same thing for the g. So f of g of x equal to f of g of x. F composite g of x. Well, the function g is right here. You basically replace all of the x of the f with that entire function. So that means for the function f, we are going to have 3x minus 7 in the blue here. Keep the exponential power, minus 4 times 3x minus 7, then plus 2. Well, let's simplify this a little more. 3x minus 7 squared is going to be 9x squared minus, let's see, 3x times -7 is -21x. Another -21x is -42x. And then plus 49. Foil the -4 in, we are going to have minus 12x plus 28. And then plus 2. Combining like term to simplify even more. Keep the 9x squared. -42x minus 12x is -54x. 28 plus 2 is 30. 49 plus 30 is 79. Okay. Now, what is the domain of the resultant function here? Or should I say, is there any restriction in the domain of this function here? Well, there's no restriction because there's no denominator. We can take any x value, plug it in, and crank out the corresponding y values. And also, we also don't have any restriction from the inside function g of x either. So really, looking at both the restrictions of the inside function, which we don't have any, and the restriction of the resultant function, which we also don't have any, the domain of the result is actually going to be from -infinity to positive infinity again, which is all real number. Now, what about g composite f integers of x, which is g of f of x? Well, for the function f in the red, you basically replace all of the x of the g function with that f function. So that means this is going to be equals to 3 multiply x squared minus 4x plus 2, and then minus 7. Well, foiling the 3, we are going to have 3x squared minus 12x. Well, let's see, 3 foiled to the 2 is 6. 6 minus 7 is going to be -1. Now, what is the domain of this? Well, same thing. The domain of the resultant function must include the restriction of the result right here and the restriction of the inside function. But the inside function doesn't have any restriction because the domain is all real numbers, and the domain of the result is also all real numbers. So no restriction from the inside function and from the result. So the domain is from -infinity to positive infinity. Okay, now lastly, if x equals to -2, then what? Then f of g of -2 is equals to 9 times -2 squared minus 54 times -2 plus 79. Well, let's see. -2 squared is 4, 9 times 4 is 36. -54 times -2 is going to be positive 108. Then plus 79. Let's say 6 plus 9 is 15 by 5. Keep 1. 1 plus 3 is 4 plus 7 is 11. So 115 plus 108. But 115 plus 108 is going to be 223. So this is the value of f of g of -2. Now, if x equals to -3, then we are going to have g of f in terms of x equal to -3, which is equals to, oops, hopefully you can see that, 3 times -3 squared minus 12 times -3 minus 1. -3 squared is 9, 3 times 9 is 27, -12 times -3 is positive 36, minus 1 equal, let's see, 36 minus 1 is 35, 27 plus 35 is going to be 62. And yeah, this is the value of g of f of -3. So the key takeaway, or should I say the most important thing, or the most difficult thing, is finding the domain of the result. Now, in composition of function, when you find the domain of the result, you must include the restriction of the function that you come out when you do the composition. I mean, after you do the composition, and the restriction of the inside function as well. So that's why earlier we had to find the domain of each function f and g individually before we decide to start composing the function. After we compose a function, we come up with this result, look at this result, and see if there's any more restriction. And if there's none, if there's no restriction in the result, and also no restriction in the inside function, then hey, we get to say the domain of the result is going to be from -infinity to +infinity, or all real numbers.